Hi guys, welcome back. So we are still looking at the concept of investigating triangles, right? Now I gave you a task just before we went to the ad break to complete two tables and try and look at the comparison that you are seeing there and look at whether the ratios that we've kind of concluded with the first angle that was 30 degrees, will they be the same as well, or will they be constant with 60 degrees, with 45 degrees? And remember, I said 60 degrees will be in the same triangle as the 31, and 45 degrees will be in its own triangle, because at the end, the sum of the angles in a triangle must be 180. So that's one thing that I said you should do just during the ad break, so that you look at exactly, is this true for every angle, acute angle that is, because we are using three acute angles, 30, 45, and 60. Will it be the same for all three? And we're going to look at what exactly is it that we are talking about when we say there's three angles that we are calling 30, 45, and 60. We're going to give them a name as well at a later stage, just to see exactly what is the bigger picture about these angles. So I hope you saw some similarities in terms of the ratios that I said you should do. You saw some differences that you saw in terms of the ratios that I said you should do, and also you could conclude something about it being constant or not being constant. But I hope you saw something that is worth seeing, because really there is something worth seeing there. Now, so far we've looked at the ratios of sides and angles. Now we're gonna talk about a special type of angle, which we call a special angle. Now, right angle triangles with special angles, they look something like this. So as I said to you, 60 degrees will be in the same triangle as the 30 degrees. This is really what I meant. You can see the 60 degrees there, there's 30 degrees, and my sides accordingly. One side that I didn't know was B, and I found it using the Theorem of Pythagoras. Now here, my letters are X, Y, and Z. You can see that the opposite ones will be the lower cases of the opposite vertex. If I'm given X and Y to find Z, I will use the Theorem of Pythagoras, which I believe you are also familiar with. The reason why this is 45 and that is 45, it's because it must add up to 90 degrees, so that they can all be 180 degrees if you add them. Now, one other thing that I also need to mention here is, with a 90-degree angle or a right-angled triangle, we normally show it with that small box there. So I don't necessarily need to tell you on the statement that the following is a right-angled triangle. I don't need to say that. As long as I say, look at the triangle below, and in the triangle you see this little square of mine there by the corner, definitely it is a right-angled triangle, because that's what we are using under mathematics to talk about a right-angled triangle. Now, you can calculate any of the 6 ratios for a given triangle with a special angle without a calculator, right? To link the ratio and the angle, we name each ratio of the 6 ratios. What do I mean when I say that? The ratios, we call them sine, we call them cosine, we call them tangent, and then we look at other 3 ratios, but we'll look at that just now. The ratio for any 2 sides is constant for a given acute angle for all similar triangles. Remember, that was the conclusion that we came to when we were looking at those 2 tables of mine with 30 degrees. And I hope you also maybe saw the same thing with the 60 and the 45. You can use a calculator also to find the angle if you have measured the length of the sides and calculated a ratio. So you can play around with this. Remember, I said The first one is if there is special angles, but now is when there is no special angles, we can use a calculator to do that, which we will also look at a later stage. To name the ratios, consider the right angled triangle ABC with angle theta. So our main focus will be angle theta. That's our frame of reference. Now, if you want to look at this triangle that I have now, and I want to name these ratios, remember the definition of a ratio will be the length of the side opposite angle theta divided by the length of the hypotenuse. And this ratio becomes what we call the sine of the angle theta. In simple terms, it's sine theta is equals to opposite over hypotenuse. Now you will see some textbooks, they use the word OPP over HYP. It's really one and the same thing. Remember, we are smart as mathematicians, but our smartness makes us lazy at times. So we shorten things so that we can just, speak about them and not have to dwell into the language itself. Now, the other ratio is the length of the side adjacent angle theta. Remember, adjacent is directly next to it over the length of the hypotenuse side. And this will then give me cosine of the angle theta. In simple terms or in short terms, it's going to be cos theta is equals to adjacent over hypotenuse. Also remember, to make it short, it's ADJ over hyp. So I'm just including this because at a later stage, I might be just writing ADJ and hyp and not writing the whole word. So I want you to please be familiar with the vocabulary that you're going to be using in trigonometry. Now, the last ratio is length of the side opposite angle A over length of the side adjacent angle theta, right? So this will be the tangent of the angle theta. Therefore, this is opposite over adjacent. Tangent is just the full word, but we call it tan. And then this is OPP, remember, over ADJ to mean adjacent. Now, the big thing here about these three ratios that I've given you so far is these are the main ratios that you're going to be using from now going forward with your mathematics career, right? If you pursue more maths in the upcoming years and all of that. So, we're going to also introduce the opposite of this, which we will then give a special name to them. To say if it's no longer opposite over adjacent and it's adjacent over opposite, what is that? Or if we say we don't call it opposite over hypotenuse and we call it hypotenuse over opposite, what ratio is that? That's what we're going to look at as well, which will make it, remember, it's always been saying 6 ratios. So the first 3 are what I just gave you now. We're just going to try and look at the tupent times of them, and that will introduce the next 3 ratios. Now, consider the right angle with now angle theta, right, also. If I say my sine, it will be that's my summary. My cos of theta will be adjacent over hypotenuse. My tangent of theta will be opposite over adjacent. So that's just a quick summary of what we've spoken about. Now, if it's now hypotenuse over opposite, right? Remember I said tupent times. We call this cosec. And in the full word for it is cosecant of theta. If our ratio is now hypotenuse over adjacent, we call it just sec. And this is secant of theta. Now, the other one also, if it is adjacent over opposite, remember tan was opposite over adjacent. Now we say we swap the ratios around, or the the numerator and denominator round, this gives us what we call the cot theta, which is then cotangent of theta. Now, a quick summary of this, you can see my sine theta is there, cos theta is there, tan theta is there. And you can see I am kind of pairing them together with what they are related to, but we'll see what is it that they are related about. Here you can see my opposite is the numerator, there it's the denominator. Adjacent is the numerator, there it's the denominator. But it's still the same things that we are dealing with there. Now, what do you notice about the 6 ratios? Are there any relationships between them? What do you think? If I looked at my first 6 ratios, 3 ratios here, is there a relationship of those ratios with that? Kind of, because we saw that we were swapping the numerator and the denominator around. But what exactly do we call that? So we call these here the reciprocals. Remember, I was using the word reciprocal when I started here. We call these the reciprocals, and we call these the ratios. So these are 3 ratios: sine, cos, and tan. And then cosec, sec, and cot are the reciprocals of the 3 main ratios. And a reciprocal will be 1 divided by the ratio, and then the numerator and the denominator of the fractions, they swap because of the 1 divided by. But let's see exactly what does this mean. You can see from what I spoke about with summary, trig ratios here and reciprocals there. Now, with a reciprocal, you can see it's 1 over sine. So 1 over sine theta, remember it's the same as 1 over opposite over hypotenuse. And because I'm saying 1 divided by, these two will swap around, because that's what the big idea was. And this becomes hypotenuse over opposite, which will then be the cosec. So I hope you remember what we spoke about. With the 1 over cos, it's the same thing. It's 1 over adjacent over hypotenuse. Because of the 1 that I'm using as the numerator, my denominator as a fraction will tip and times, and it will then become hyp over adjacent. So that's what we are talking about when we talk about a reciprocal relationship. Now, for any right-angled triangle, you use the equation from the Theorem of Pythagoras to do what? To calculate the length of a side if you know the 2 sides. Remember, what was my big question to you? Can I find one side given one side or given 2 sides, right? If I know the 2 sides, I can find the 3rd side using the Theorem of Pythagoras. But what must be the condition? It must be a 90 degrees a triangle, right? So there must be a 90 degree in the triangle, meaning a right-angled triangle. So I can use that. So meaning, can I find one side given 2 sides? The answer is definitely I can. How so? Using the Theorem of Pythagoras. Now, the other question that I asked you was, can I find one side? If I'm given just one side, then here I can. For any right, I can use one of the trig ratios to calculate the size of the acute angle if I know the length of 2 sides. If I'm still given 2 sides, I can find the length or the size of the acute angle. So this was about the relationship that we spoke about in terms of angles and the sides of a triangle. Again, with a special angle, you use one of the trig ratio values to calculate the length of a side if you know the length of one side, right? So I want one side and I'm given one side, but I must also be given an angle there. So this answers the other question that we had that had to do with, can I find an unknown side given just one side? And is this true for all angles? Yes, because we are saying for any special angle. Remember our special angles, we did say that it's 30, 45, and 60 in that order, because they must be acute angles after all. So that's what we are talking about here. So meaning, so far we are answering the questions that we started with. And the first two questions that I asked you, definitely we can do it, because we'll use either the theorem of Pythagoras or use the trigonometric ratios. That's what we can use so far. Now, for a right-angled triangle, although there are 6 ratios, a calculator only shows this one, that one, that one. So it only shows sine theta, cos theta, and tan theta. Then the other 3 ratios are the reciprocal ratios. Now, what does this mean? It means that I can only see sine, cos, and tangent. I think if you're on your calculator right now, any scientific calculator for that matter, I promise you, you will see them. They are written cos, sine, and tan, but it starts with a sine. I think it's the 3rd row when you just after your cursor on your calculator, on a scientific calculator that is. So just have a look at that. On your calculator now, press the sine, press the cos, press the tan, and tell me what you see. And then you will see that's what we are talking about in terms of the 3 ratios that we can have on the calculator. If I want to find the other 3, I will do what? 1 divided by sine, 1 divided by cos, 1 divided by tan, and that will give me the other 3 reciprocals. So make sure that you are familiar with this. So just on your calculator now and try and press these things that I'm saying so that you can just see it. And then in our next lesson, we definitely gonna dwell more into all of this. And I will show you exactly what do I mean when I say press this, and where do you find it in terms of your calculator. Now, the other thing is, remember we looked at the big idea, which was triangles. We're investigating what triangles are all about. Said it's when there is 3 sides, right, and also 3 angles. Those angles, they must add up to 108. In specific, we looked at one that has an angle that is a 90 degrees. So that was the main triangle that we're looking at and we're investigating. Because of a right-angled triangle, we can then use what we call the Theorem of Pythagoras, and that's only because there is a 90-degree angle in that particular thing. You can see, even if you were to go to Google and just look at the history of the Theorem of Pythagoras, it was only discovered because of a right-angled triangle. Now, from there we can look at the concept of ratios of sides and angles, and the ratios, remember the 6 of them that we spoke about, the main 3 that we can find in our calculator, and the 3 that are reciprocals. And then the last thing was our special type of angles, which we call the special angles, and those are 30, 45, and 60 degrees. Guys, I hope you've learned a lot in terms of how do we then look at the vocabulary and also look at the big idea of what trigonometry is all about, because that's what I've been trying to do with you here. We've been trying to investigate triangles. Why? Because that's the big idea of a trigonometric question at this particular level of ours. For now, I would like to say goodbye to you, and I will see you next time.